Video, we have seen how to draw such a curve for a specific energy for open canal with varying water depths and varying specific energy. In today's video, I will look how to draw another curve with the same example I've used last time, but now with varying discharge and varying water depths but constant energy. Well, the main difference between today's example and last time example that the discharge in the last time was constant, but in today's video the discharge will be varying as you can see in this curve. Now let's look at this example and show you how I created the data set for this example and this cross section. I'll start by adding the water height. It's just nothing but I'm adding it to be point at increment of zero point 0.1 meter until 6 meter height. So this is 6 meter height, and the canal width is 1.5 meter. The area is multiplication of these two values, the height and width. The energy is I'm using this equation, potential energy and kinetic energy. So again, double click to fill the rest. And now at this point, about to find out the discharge value because I'm fixing the energy to be 6 meter for this specific example. You can use any value you want for the energy. You can use 10, you can use 15, but be careful that when you specifying energy value, you got to look at the values of the geometry of the cross section and the area cross section as well, so that you get a realistic data and a realistic example and realistic calculations. So at this point now, after to find out the discharge for all these values to be plotted against H water stage for fixed energy 6 meter. Let's look at that. So let's look at this example and how to work out the discharge value for 6 meter energy. So I'm assuming the energy to be 6 meter and the energy is given now 6 meter. The height is given. All this is the height of the water. The discharge is missing. So we need to work out the discharge that gives you 6 meter. Yeah, I'm just assuming 6 meter. You can use any value of energy, but you gotta be careful with the geometry. You need to maybe to if you increase the energy, you need to increase the maybe the width or maybe the height, so you can get a realistic sort of uh, engineering sense. Now let's look at this bit of calcs I've created. So look at substituting 6 assumed value and zero point 0.1 meter. Discharge is now solving for discharge to get 1.61. This is Q, not Q square. So Q is 1.61, and this actually can be done by doing a goal-seek analysis. So go to data, what if analysis, change this value to be 6 meter by changing the discharge. So let's look at what discharge we got. So it's 1.61, and this can be also done. The rest of the data can be done for goal seeking analysis. To do that, I've created a macros, and this is another useful function that you can use to run any sort of analysis. So I can run it in the background. There you go. I'm getting the values of the Qs for the fixed energy 6 meter. So fixing energy, get the values, fixed energy, get the values. So again, this now I got the Q value, I got the height. So now we get to look at the at the curve. Well, now we got the curve is plotted, and this is the curve I'm all about in this video. The one on the right hand side with fixed energy in the system. So our canal is 1.5 with varying water stage and fixed energy, and this is the curve we get. So looking at this curve actually is clearly seen that the water depth increases, the discharge increases as well. So until a certain point that the water is the water discharge is decreases. At this point is the critical depth, and the critical depth YC is or HC is really the depth at which the water is flowing at its maximum. So this is the maximum energy. I mean the maximum discharge, no energy. And this actually this can be calculated by using this equation, and just the Q is nothing but the maximum discharge, and the B is constant, G is constant, and just you can work out the Q, I mean the HC. Looking at the curve, actually is at this point the again the velocity and the discharge decreases. This is why, because the potential energy in the system is increases. So as the potential energy increases, the kinetic energy decreases. This is how to balance the energy in the system. So, and this goes on and on until a certain point that the discharge is zero. And you might say, well, how the discharge is zero? Actually, the discharge is not zero. There's water in the system. There's water in the canal in the cross section, but this water at this point is standstill. So there's no water moving anymore. So the whole energy in this canal is now dominated by potential energy. There is no kinetic energy whatsoever. So this is quite useful and handy to explain the concepts in this curve, and how this really can be useful for hydraulics engineer for designing and to understand the concepts behind the energy concepts and discharge and water stage. Hopefully you enjoyed the video, and thank you for watching, and speak to you soon.